is 2, 2, 3, 4. Can you find the inverse of this matrix, please? Follow the steps line by line and give me the answer. So your determinant is, what is your determinant? Determinant is the leading diagonal, 2 times 4. Take away 3 times 2. So it is 8 minus 6 is 2. Then you swap the leading diagonal elements, 4, 2, and you place a minus here, negative 3 and negative 2. And you finally divide all of that by 2, the determinant. So basically, even if you don't know the regular by hand calculation, just place a 2 underneath it. 4 over 2, minus 2 over 2, minus 3 over 2, and 2 over 2. Even if you do this, you'll be fine. Mitch, is it okay? Yeah? Alright, and you can do that on the CAS if you want to. Now, you could have something like solving the matrix equations. So shall I take this off the board, please? Solving the matrix equations. Now let's say you have a matrix B equals to 2, 1, 3, 2, and another matrix you have which is C, which is 8, minus 1, 4 and 6. And let's say you've got a question like this: x times b equals to c, and you're asked to solve for x. Now, I just explained you the algebraical way of doing it is you take the b to the other side. So x is b inverse c, right? Mind you, never do it like this, c times b inverse. No, don't do this. In the world of matrices, order is very important. The inverse matrix comes first, followed by the other matrix. Alright? Now the next step is find the inverse of b. Can you please, now you've understood how you find the inverse. Can you find the inverse of b for me, please, quickly? All the steps that you've just learned, and then we will write the inverse here. Quick, find me the inverse of b. Okay, what's the inverse of b? So I'll find the determinant first. Determinant is 2 times 2 is 4 minus 3, which is 1. And then I swap the leading diagonal. I say 2, 2 remains the same. And I place minus 3 and minus 1, and I divide it by 1. So basically, my inverse is 2, negative 1, negative 3 and 2. Yes, Mitch?
Divide by 1.
Sorry?
Divide by 1.
Divide by 1 basically is one and the same thing. No, one division is the same number.
Yeah.
Now you place the C matrix along. 8, minus 1, 4, 6. Now if you multiply these two matrices, the way I explained you earlier, you finally get the X matrix. What will be the order of the X matrix? Can you tell me? Mitch, what will be the order of the X matrix? Sorry? What is the order here?
2 by 2.
What's the order here?
2 by 2.
What's the order here finally? When you multiply them.
2 by 2.
Awesome. Because they're equal, that's the order. Do you want to multiply these matrices by yourself or are you fine? Try this. Try multiplying. We'll see how much do you remember from last time. Chuck this off. It's less confusing. And this is a 4. This is a 4. All right. Which I'll just quickly do that. Validate, please. Okay. First row, first column, 2 times 8 plus -1 times 4. First row, first column. Go to the next column, same row. 2 times -1 plus -1 times 6. Then another column, no, switch the row here. -3 times 8 plus 2 times 4. Yeah, and then switch the column, -3 times -1 plus 2 times 6. Mitch, is that okay?
Yeah.
Right? And a plus always comes underneath when you're switching the elements. And you solve it. Okay, we can give you the final answer. What's the final answer now?
12, -8,
12
-8, -16 and 15.
minus 16 and
15.
that is the value of x. Solved it. All good? Quickly, if I take this off, all of that. Mitch and Gary, if you can do me one favor quickly, can you guys do B multiplied by the identity matrix I? So that means B is 2, 1, 3, 2, and I is 1, 0, 0, 1. 0.
Will be the same since they're identity.
Whenever you multiply any matrix with identity matrix is like number 1 in the world of maths. So when you times anything by 1, you get the same number back. 3 times 1 is 3. Similarly, when you multiply any matrix by the identity matrix, you get the same matrix back. Blindly, don't dive into it, okay? Just blindly do that. Normally in the world of matrices, we say order is very important. But that rule is not true when you are multiplying it with identity matrix. So for identity matrix, I times B is equals to B times I equals to B. So whether you place identity matrix before the any matrix or after, you still get the same results. That's the exception to the order in the world of matrices, right? And one more rule of matrix is that if you multiply a matrix A, let's say any matrix A, with its inverse. What is inverse? Inverse is basically over 1, no? So it's A over A. A cancel, you get 1. In the world of matrices, 1 is the identity matrix. So it's I. So any matrix A times its inverse in any order will always give you identity.